Okay, so basically last week we only managed to do 1.5 sessions out of the 4 that I planned. So what I'm going to try and do this week is make up for lost time. And what we're going to do is today I'm going to finish off hopefully the majority of the important stuff around alarms and events and around mib parsing for alarms and events. And then my colleague, Ronnie Tromer, is going to talk about performance management tomorrow on Tuesday. Wednesday, we'll be back with me, and I'll be talking more about alarm processing, but I'll be looking at other aspects of alarm processing, things like event translator and forwarding of alarms and events to other systems. And then on Thursday, which we originally hadn't planned, Ronnie's going to come back and do more on performance data collection. I won't be here on Thursday. Usually I'm teaching at the university on Thursdays, so I won't be there, but the plan is that on Thursday, Ronnie will take it. And then on Friday, we'll wrap up. Now, I appreciate that we may not have covered things as well as we would have hoped. And what we may do is end up rerunning some or part of this material later on, but we'll have to talk about how and when to do that. But what I really wanted to do is make sure that you respected your time and that, this week we got the majority of the work out of the way. So before I go any further, have we got any questions from the material that we did do up until last week?
Not for me.
Okay, probably questions will come up as we go along. So
surely, don't be worried about that. They will come.
Yeah, they will. Okay, so just to recap what we did, so we remember, session 1, we did a basic introduction to OpenNMS. That was really a demo, and we went through some slides explaining the architecture, and we created a few alarms and showed that happening on the screen. So that was fairly simple and easygoing. Session 2, we started looking at, and I'll just throw this up for you to see, the configuration of OpenNMS, where the files live. And we did get this far, but where we didn't get to was onto the exercises, which were looking at how to inject traps into OpenNMS and how to do traps and alarms. Now, what I'm going to do this session, just to start off with, is I'm going to cover some of that very, very quickly, just so we can get going. But then what we're going to do is go on to session 3, which is this week's session, where we're actually going to be looking at a worked example around how do we monitor these cameras that exist on a motorway using SNMP. And we've done a full worked example of that to show you how to do that. And that's what we're going to go through today. And there'll be exercises for you to do in your groups. And hopefully by the end of that, you'll have a very good understanding, or at least know where to look to find out how to alarms. Okay. If you're not speaking, can I just ask you to go on mute, just because of the recording. So let me just jump back to this exercise 2.3. Actually, just before I do that, the other thing I need to remind you of, if you remember, I said that you should fork the repository, and I can see that some of you have, but some of you probably haven't yet. Fork the repository, and then you do need to update your fork of the repository with my latest work and with Ronnie's work as well when he contributes it tomorrow. And you can see how to do this under this bit, getting started with Git. Right down at the bottom, it tells you how to add a remote upstream, which in this case is my remote upstream repository, fetch it, check it out, and merge it with your fork. Okay, that's really what you're trying to do. You're taking in the extra material that I have added since our last session and putting that into your repository. And then when you do the exercises, please actually copy the session into this My Practice coursework in your own fork. That way you can keep a copy of everything that you've done and everything that you've changed. But I also can change the sessions, add material, modify, correct them, and it won't upset anything in your repository. So don't actually work in or touch any of the folders in this repository, except for My Practice coursework, which is where you put your work. And you basically copy the session into there and then work in that session. And then you can check it in and save it, and you have a record of your own work in your own repository. Okay, so maybe while we're getting on with this, you could try doing that now, getting your own repository up to date with my latest work. Now, a couple of other things that I just want to remind you of. This particular folder here, pristine OpenNMS config files, contains two things. The first thing is the pristine etc. directory that comes with OpenNMS 32.05, which is the version that we're using in our Docker examples. This is the etc. directory and all the files that would be in it. So if you want to go back and look at what the file should look like before you've touched it, you can look at all the examples here of what these files are. Okay, and clearly we don't have time to go through all of them, but they are obviously covered in the OpenNMS documentation, but they're here for your convenience. And then the other thing is that the XSDs for the XML configuration files are all included here as well. And we're going to particularly be looking at event.conf, which the XSD is here. And this basically, if you want to get into it, explains all of the fields in the event configuration and alarm configuration file. And there's documentation for all of these fields. So there may be stuff that you'll see and say, I don't know what this is for. This will actually explain it if you want to go into this document to understand what these things mean. But again, it's provided for your convenience. We won't actually be looking at that in any detail as part of the course. Okay, so let's go back to where I was jumping off from, which was session 2. And what I wanted to do was to look at how to create events and alarms in OpenNMS. Now, we talked about provisioning requisitions, and this is my OpenNMS web console. I've got it running based on the session 3 minimal minion active MQ. I've already put in Docker compose up -D. I had cleared it all out as well previously with Docker compose down -V. So I started from scratch. And you can see that the whole thing is running. And if I wanted to see the logs, Docker compose logs horizon or -F, which follows the logs horizon. And these are the logs that have actually come up as the system's been starting up. But once it runs through the whole set of logs that it has in the system, hopefully we'll see, basically when the system's up and running, you should have something like invocation start successful, and it should be at perspective polar, because that's the last thing that actually comes up in OpenNMS. So if everything's gone well, that's what you would get. So that's my OpenNMS running. And if I go to my login for my system, it's obviously localhost 8980. Admin. And we can see that this pristine system has 2 nodes in it. Let's have a look at the nodes. And the nodes are localhost. If I click on that, we can see, it's already collecting its own statistics. It's collecting its own database information, and it's collecting its JVM information. It knows that these processes are running. But it also knows about a minion. Now, when the minion comes up itself, it actually registers with OpenNMS and says, I'm here. So the minion doesn't actually need to be provisioned in the provisioning requisition explicitly. If a minion appears and it's given the coordinates to talk to OpenNMS, then it will communicate with OpenNMS and it will show up in the OpenNMS node list as one of the things that OpenNMS is monitoring. And you can see here that the minion's running, and JMX minion basically is JMX statistics from the minion, and it's also got a heartbeat and remote procedure process running. So, you know, the minion's running fine.
Small question. Small question.
Yes.
What I don't understand here is that why do we have the minion already present from the UI, knowing that you have just started the Docker with the option -d. So for me, -d means that we want to clean up the database, if I'm not mistaken.
No.
No?
-d means we want to start it as a daemon.
Ah, sorry.
V
Yeah, sorry.
means delete
Yeah,
the database.
-v. Yeah, -v. Yeah. Sorry, I mixed both.
That's okay. It's a simple mistake. All right. So yes. So if we started with -v, we would be waiting for a minute and a half the whole thing to come. Right.
Okay, thanks.
So, great. Okay. Any other questions? There's no silly questions. It's perfectly reasonable if you.
So in this case, we have some special configuration for Minion to start along with OpenNMS itself, right?
Yes, that's correct. Now, I haven't covered Minion configuration, but in the example, if we just go to the ActiveMQ and look at the container file system, you'll see that there's a configuration for the minion, this minion config.yaml, and that tells the minion its name, minion01, and it gives it the broker URL and the URL of OpenNMS, so that broker is running in OpenNMS. That's ActiveMQ, and it's running as part of OpenNMS. So whenever the minion starts up, it looks at this configuration file that says, I need to talk to this broker, and I need to know that it also needs to know that this OpenNMS is the address of OpenNMS. If it has that information, then it will start up and it will register itself with OpenNMS. Is that clear?
And it's running like a separate process, right?
Separate process, separate Docker container.
Okay.
So again, if I go back, let's look at the Docker Compose. You can see that we've got the database, we've got Horizon, and then we've got this minion. So it's running in a separate container. It's connected to the network, and it's been given its configuration. So you can see here the minion config.yaml has been injected into it. Okay.
From here, what I see, communication between minion and server is unencrypted HTTP.
Yes.
And most of the customers are very concerned about security. So I guess it's possible to set up communication to HTTPS.
Yes, yeah, but I haven't covered that. I'm just keeping it simple. But yes, that's right. Now, in fact, truthfully, I think that the minion now exclusively uses either ActiveMQ or Kafka to communicate with OpenNMS and doesn't actually use the URL anymore. I'm not absolutely sure of that. So it may be that that bit of the config's changed, but we would need to be setting up HTTPS anyway in OpenNMS, but I'm not covering that part of the OpenNMS configuration in this unit.
And the ports we see here for TCP, UDP is the ports which are exposed to get the traps, right?
Yep. So 1162 is to get the traps, and I think this is to get syslog. Okay. If we just go back to the container file system and look at the minion again, let's look at the config. You can see that syslog is running at 1154.
Yeah, okay.
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 So let's just go back and look at the alarms, because you know, the minions is a whole separate topic, really. But fine, thank you for the questions. Okay, so where were we? Right. Okay, so we have our simple OpenNMS. Now we also have a provisioning requisition set up to match the network that is in in the Docker Compose. So these are the nodes that are in the network. Again, if I just go back to the example, look at the Docker Compose, you can see that right down at the bottom, we've got the minions, and then we've got these various little SNMP containers. The 1.1, 1.2 are all on one side of the network. And then there's a few things called Chub Camera. And then there's SNMP 2.1, 2.2, which are on the other side of the network. Okay, so again, if I just jump back and look at the way this is set up, I'm on session 3, so I need to make sure I'm looking at the right thing. This is the network that we're actually looking at, he says. Trying to find it. Yeah, so this is basically the network that we're looking at here. Okay, so we've got OpenNMS, Postgres, we've got a couple of SNMP containers, we've got this thing called SNMP sim, which is representing camera 1, and then we have a minion, and then the minion, the other side of the minion, in a different subnet, we've got a couple more SNMP containers, and we actually have another camera as well sitting on that side. Okay, so that's our network that's set up in Docker Compose, and then our provisioning requisitions match that. Okay, now the one thing I'll point out, which somebody did ask before, is that because the minion is discovered by itself, the minion registers itself, I've actually put the minion into this particular provisioning requisition, but it doesn't need to be there. And so we'll actually end up with 2 minions. I'm not going to change it now, but you probably wouldn't need to put the minion actually in the provisioning requisition, because it's already been provisioned in a separate requisition. So let me just synchronize this, get and scan all the nodes, and we'll get those into the OpenNMS database. So again, if you now look at the nodes, we should see, you know, they're all gradually coming up as they register themselves. And the next thing we need to do, if you remember, is that the chub mib actually needs to be using the right community string in order to find out that SNMP is actually running on this particular device. So to do that, we need to look at setting SNMP community strings. We do that by IP address. And again, I just want to go back and remember what the IP address of those nodes is. And 103. So I'll just put that in, look it up. And we can see down here that it's set up as public. It needs to be chub. You can save that. And 203. And this time it's not under default, it's under minion1 location. Look it up. And again, you know, change this to chub. Save the config. And now, hopefully, go back to the nodes. Still isn't showing up. What we actually need to do then is just rescan that node, which should, hopefully, if we re-import it, if we resynchronize the requisition, it would do the same thing. But I'm just going to do this quickly. And there we go. Right, so it's there. And let me just rescan the other one as well. So we've got it. So having changed the community string, ultimately the system will find that the node has changed, but we're just forcing it to rescan, so it'll find it a bit quicker than it otherwise would. That node is actually responding to SNMP. So, and there we are. That's it. Okay, good. So we're now in a place where we've got all our nodes in the system and we're receiving events and alarms. And we want to now look at how we actually receive events and deal with them in the system. So we can see there's a load of events already in the system as it's been provisioning it. The system talks to itself and generates events as things happen, and those get logged. Now we actually want to create some useful events, hopefully. And what I'm going to do is work my way down to the bottom of this. I'll go to this one here. In fact, I'm going to skip down to this one. And I am going to actually generate a trap. So I'm going to log in to that NetSNMP 1.1. And let me just do that. So I'm now in that SNMP 1.1, and I'm going to force a trap into that device. And you see, okay, I've generated that trap. Now, if we go back to OpenNMS and we look at the list of events, the fair wind, we can see that there is a new trap, okay? Now, this is called an unformatted enterprise event. By unformatted, it means OpenNMS has received a trap, but it doesn't know what that trap means. It's got no configuration for that trap. So by default, what OpenNMS does is it says, I will generate an event that tells you a trap has been received that I don't know what to do with, but I'll give you useful information in this trap. So what you can see in the trap, what we've got is we obviously know what node it's from because we know what IP address it was sent from, but we don't know anything else. It assigns this enterprise default UEI, and then it says received unformatted enterprise event. Tells us what the enterprise OID is for that event, the generic and specific strings. And then it tells us that there are 3 arguments. First argument has got this OID, and it's just got XXXX as the value. The second one's got this OID, and it's 0. And the third one has got this OID, and it's 1. Okay. If we go down further and look at the description, what it gives us is what we call a mask element. And the mask element is what tells us how to match for this particular trap if it ever happened again. So if I was going to build a configuration for a device that I didn't have a MIB for, but it was sending me traps and I needed to do something with that, I could receive the traps, and this particular event would tell me how can I construct an event and an alarm that will match for this trap. And to do that, I would use this mask element, which uses the ID, which is obviously the OID of the trap itself, the generic and specific values, which are again part of the trap. And that, if that was put in as part of the mask, that would actually match for this particular trap value. And then we would then have to work out what to do with the arguments, but that would be the next step. Okay. So
do you mean that even if we don't have the SNMP MIB to decode the event, do you mean that thanks to this mechanism we can nevertheless enrich the traps with some fields even if we don't have the SNMP MIB? That's the goal?
Yes.
Okay.
That is the goal. Yeah. It's to help you, yes, exactly. It's to help you understand that there's a trap coming in you don't know anything about. It gives you enough information to either go and find the MIB if you can't find it because it gives you the OID, but it also gives you information that would allow you to create your own event definition for this trap. Sometimes you create traps, for instance, if you're using an SNMP to generate new traps, you may not have a MIB for those traps. So you would still need to create an event definition for it.
Okay.
So yes, that's correct.
Okay, thanks.
Okay, so what would we do with this then if we wanted to actually create an alarm for it? Well, I'm going to just jump through. Now, I would have covered this in a bit more detail and got you to do an exercise, but I'm actually just going to go through it quite quickly just to give you the idea and then get you on to a real exercise based on this. So what we can see here is an event definition that matches that particular mask that we were going after, okay? So if I just jump back a little bit and look at the pristine OpenNMS config files again. And I'm going to look at event.conf. And under event.conf, event.conf.xml, what you can see is that the event.conf, which is the configuration for event.d, basically contains a list of files that contain events for different manufacturers. So we can see here under events, we've got manufacturers for, 3Com, Adtran, Air Defense, a lot. There'll be Cisco down here as well. Should probably be in alphabetical order. It probably is Brocade. But these are traps that have been worked on previously, have either been contributed by the community or have been built up over time that are known to work with these devices, and they're already included in OpenNMS. If you want to create more traps, then you would essentially extend this file, add an extra event file reference into this, and then create the file itself in the events folder. If we look at the events folder, we can see all of these devices are in here. You would add into this your new event definition and then reference it for an event comp. Let's just, I'll just pick one of these at random just so you get an idea. And you can see that, basically the events are all defined the same way. You have an event mask that determines, what trap is actually going to generate this event. And you can see, it depends on the OID, which will come from the manufacturer, the generic, and then the specific information. And if all of this matches, then this particular alarm will be event will be generated. And you can see that this UEI will be attached to that event. That's the unique event identifier. And in this case, it's WS VLAN link up. There will probably be further down a VLAN link down definition. And then the rest of this, the description, is actually HTML, but we're using the escape characters here rather than less than characters, simply because you can't put HTML within XML easily. So we simply put the HTML that will show up on the screen as using these escape characters instead of less than. And you can see it, it's going to generate a variety of information. And there's a load of events here for this device, and for every device over time, we've created more and more of these. Okay, so let's go back to that example that we started with. Sorry. Right. So back to session 2, back to this example. And we can see that in this case, we're masking with, and this is masking for that trap that we sent. We're masking against the OID, the generic and the specific values. So again, if we go back, we'll see the generic and the specific values. but we're also masking for a specific value of the arguments. So these arguments are called var binds, and the var bind consists of the OID and then the actual value. So in the configuration, you can see that var bind number 3, if it has value 1, then this mask will match. So we've got this trap, we've got the specific and generic values, and then if var bind 3 matches value 1, then we will create a raise example trap definition. And if we go down to the next example, same thing, but in this case, var bind value 0, we will create a clear definition. So raise and clear. Okay. So what that is allowing us to do then is to break the trap down into what values it's providing, because the trap itself, you know, may contain information that's required to give us much more detailed alarms and events from a device. In this case, our simple example is saying that you know, we're sending a trap, and the trap, if the var bind number 3 is 1, then we've got an alarm that's been raised, and if the var bind number 3 is 0, then we've got an alarm that's been cleared. Okay. Now, just going down through
so
this.
Here, sorry, Craig. So here again, we assume that we don't have the MIB, the vendor MIB, right? We are still in that case.
That is correct. That is correct. Now, what I will do is I'm going to get you going on an exercise where you'll actually start with the MIB. But I want to just give you how this works before you start on that. Otherwise, you'll get a little bit lost.
Okay.
Yes,
sure.
We don't have the MIB. Okay.
Yeah.
So the event label, it's very simple. So, you know, it's whatever you want to call the event. The description is what's going to show up in the description in OpenNMS. So again, if we look at this, you know, the description, this is what shows up in the description. And then the log message is a short message, and that just shows up here, short message, okay? The short message. Now, you can see that we can actually take the var binds and include them in the message. So we can see parameter 1, and it's been escaped with a percentage sign. That will actually show up as the value for var bind 1 or var bind 2 or var bind 3. Okay. So again, if we look at the events here, you can see this value showing up here, here, here. Those values are actually, and then the same up here, there, and there. Those values are actually coming from the var bind, and they're being picked up using these simple escape sequences that actually pick out the value from the trap and include it in the text of the event. So we can do descriptions, we can do log message. You can see here that the log message destination says log on display. Now there's various different variations in this, but basically it comes down to log on display. It will save it in the database and it will display it on the screen. But there's also do not display, do not log, do not display. I can't remember the exact term, but we'll cover that later. But you can set this up so that an event comes in and you don't save it in the database and you don't display it on the screen. Now, what I hope to do on Wednesday is talk about what's something called the event translator, where you've got events coming in and you don't want to use those specific events that have arrived. You want to translate them, enrich them with extra information, and then display the enriched event. So in that case, what you'll do with the log message is set the destination as do not log, do not display. The event will come in, it'll be processed, and then it'll be thrown away. But it having been processed, a new event will be created, and the new event will be the one that's displayed, not the old one. Okay. But most cases, you want it to be set up as log on display. The severity is obviously, there's 5 levels of severity. And again, if you look at the exercise 2.3, you'll see what those severities are. Normal basically is, nothing is wrong or something has been restored, but it goes right the way up to critical. Those are obviously increasingly severe. And one of the things you need to work out is, given a particular trap, what severity do you want to assign to that trap? Because the trap itself won't tell you how important this trap is. You've got to work that out yourself from whatever your business use case is. We don't, in event definitions, actually use the severity cleared, because the clear will actually be generated for us as part of the alarm processing. So that's giving us the ability to create events. Now, the key thing I want you also to realize is that we've got this idea of this alarm data reduction key. Okay. And there are two types of alarms: alarm type 1, alarm type 2. Alarm type 1 applies to events where it's a raising event. So in this case, whenever this UEI comes in, raise, we get this event generated, then we will create a new alarm. And the reduction key associated with that alarm will be the UEI. So you see the UEI here, the DP name, which, to be honest, basically just corresponds to the minion or the polar that's actually been collecting the data, and then the node ID. Now, effectively what that means is that the reduction key is going to be unique for a particular alarm from a particular device. And if you have a trap coming in that creates this alarm from that device, you will generate that alarm. If the same trap comes in again, then instead of creating a new alarm, it'll recognize that we already have that alarm, and it will just increase the count of the alarm. And you'll notice that the alarms have alarm counts associated with them. Those are the counts of events that have come in. And you can have a situation where you've got a trap storm, device is just sending out lots and lots of the same traps all the time. I'm in trouble, I'm in trouble, I'm in trouble. And instead of creating lots and lots and lots of alarms, we create one alarm, but we count the number of traps that have happened. We do save the events, but the events are not the thing we're running off. We're running off the alarms now. And we only want to have one alarm because it's the same alarm. It's just we're being told about it repeatedly.
And so in case we have similar alarms, so matching the reduction key, okay, the counter will be augmented.
Yes.
With the number of similar alarms matching this, but is the new similar alarm will be forwarded to external components such as the OpenNMS adapter in that case, or not?
So the adapter has two parts to it. You can register for events and you can register for alarms.
Yeah.
If you register for events, you'll get every event that gets sent into the system.
Okay, so even the similar. So
yes, that's right. They won't be duplicated. If you register for alarms, you'll only get the alarms. So if an alarm changes, if it gets deleted or changes severity, then you'll get an event corresponding to that alarm change. Okay. So if you're registering for alarms, you just get the alarm state, and the alarm state may change. But if a new event comes in associated with that alarm, then we won't. I think there may be a config for this, but generally speaking, we don't send a new event every time an event comes in for, that changes the count on the alarm, because the alarm itself is not changed.
Mm-hmm. Okay. So in that case, there is no duplication of the event towards the OpenNMS adapter when the reduction key is enabled. Okay. No alarm forward in that case, if I want to understand.
I'm not exactly sure how you've. First of all, I don't know exactly how you've implemented your alarm adapter, but if you're using the Kafka alarm forwarder, then the Kafka forwarder is going to synchronize the alarm list on your system with the alarm list on OpenNMS. Okay.
Yeah.
It's you know, if a new alarm happens, you'll get a new alarm on your system. If an alarm gets cleared or deleted, it'll go away. What it won't do is send you an event every time there's an event underlying OpenNMS.
Okay.
It's only if that event causes the alarm to change will you get a new event.
I see. Thanks.
Okay.
Yeah, regarding reduction key, is it possible to insert trap barbines here, like parameter #1 and so on?
It is possible, yes. It is. Yes, it is. I mean, there's lots of ways you can use this, and it is possible to do that. You just need to be careful how you do it, because it is generally better to create a new event definition rather than try and use the reduction key in a clever way. It's generally better to actually have an event definition for each type of trap you might have coming in, or each variation of parameter you have coming in, and use the varbind mask rather than try and use the reduction key to do the same thing. But it is possible to do that. And there's certain circumstances where it might be a good idea.
Yeah, and those internal variables like UAE, DP name, they are documented somewhere, I guess.
They
Should
are.
be much
They are
more
documented in the, well, they're in the documentation, the actual OpenNMS documentation, but they're also in the XSD that I showed you earlier on.
Okay, thank
So
you.
there's a lot more detail in the XSD in terms of the documentation of the fields in the XSD than I'm necessarily going into here.
Could you please remind me the acronym of UEI, please?
Unique Event Identifier.
Okay. Okay, and this UEI is calculated by OpenNMS itself, or is it already embedded into the traps received by OpenNMS?
This is an OpenNMS event identifier that we have created. So whenever you create an event based on a trap, the traps identifier is the OID, obviously. Okay. So what we're doing is saying, well, given that OID, given this extra information, we want to create an event. Every event in OpenNMS has to have a unique identifier. So it doesn't matter what you call it. This is just by convention, the way it's been set up, but you can call it anything you like, as long as it is unique. The other thing to note is that if you've got a duplicated event identifier, say you've accidentally put the same identifier somewhere else in your config, it'll always be the first one that OpenNMS encounters that will be used.
Okay, so here in your example, the UEI is a unique ID corresponding to the match, to the combination of the trap OID plus the generic value plus the specific value. Plus the
varbind.
What else? The varbind, and this makes it unique, right?
Yes.
Okay.
Yes.
Okay.
Yes.
Thanks.
Yep. And as I said, you know, the first match that happens is the match that gets done. So if you've got more than one example of this in your configuration, it's possible that the first match will be the one that is actually used, and the others will be ignored. So you need to be careful, make sure you don't accidentally create more than one match for this. Okay,
Do you have some graphical alarm configuration tool? Because
there is.
It's easy to make mistakes in XML and then waste time debugging.
Yes, but the truth is it's actually easy to make mistakes in the graphical tool as well, and it's less flexible. So I'd rather show you how this works, and then you can decide whether you want to use the tool. The tool's it's fairly trivial in what it can do, but what it can't do is make it easy for you to create alarms and do alarm processing. So yes, there are, this is something that you don't do very often. But if you do it, you need to go through a process, and that's what the exercise that we're going to do next is going to be looking at, what the process is. But yes, it is, there is possibility of getting this wrong, but, take it carefully and particularly use an IDE, or a structured text editor that makes sure you don't get the XML wrong, and you should be fine. Just takes practice. Okay, so that was alarm deduplication. So we've got our alarms. We've assigned a severity of warning to our arrays. How do we deal with the clears? Well, we know that this incoming OID, again, it's basically exactly the same trap, but in this case, the varbind value is going to be 0. We're going to call this a clear UEI, and we want to use this clear to actually clear any alarms that have been generated by this first trap from this particular device. How do we do that? Well, in this case, everything is pretty much exactly the same, except for the alarm data, where we now have an additional field called the clear key. We've called this alarm type 2, which is going to tell the system that this is actually an alarm that clears other alarms. And the clear key will contain the UEI of the alarm that we are clearing. So that UEI, trap definition raise, is the same UEI as we have defined here. Okay. So if we just look again, you can see it's that UEI, that's the actual thing that we want to clear. And then the DP name and the node ID are again just going to identify that, this is the same node. So we're basically saying that if we receive this particular trap, which we're going to correspond to this clear here, then we are going to clear any alarms that have a matching reduction key, which is this UEI plus the DP name and the node ID. And the only other thing that's in this alarm data is it has its own reduction key. So if we received more than one clear trap, then we wouldn't get a whole load of clear alarms. We would get, one clear alarm and perhaps a count of traps for the number of times it's trying to clear. But essentially, what we're actually going to do is use this to clear the other alarm. And we've set, in this case, the severity to normal. You could set it to clear, but we're setting it to normal because basically we're saying that we've received an event coming in that's saying that, the situation is now normal. We're okay, we're fine. But as a result of this normal, we're going to clear the other alarm. And so the alarm itself will actually be cleared as a result of this normal event.
Is it
Okay,
possible to clear several alarms with single clearance alarm?
No. Well, yes, but not this way. It's not possible to have more than one clear key associated with a particular trap definition. At least I'm not aware that it is. If you look at the XSD, it may be possible, but I don't believe it is. So you can only clear one type of alarm with a clear alarm, but you can use more than one clear event to clear an alarm. So if I had, several traps that all of which had the effect of clearing an alarm, then I could define more than one trap that would clear the same alarm. And in fact, the same way I could define more than one trap that would raise an alarm. But you can't clear more than one alarm from any given trap. Now, having said that, there may be a way of doing that with Events Translator, but we'll talk about event translation on Wednesday. I don't want to get into it now.
No, but let's imagine we have 10 similar alarms, or
Yep.
From a warning to major severity, let's say. Okay, anyway, let's say we have 10 similar alarms. As soon as we get one clearance trap, all the 10 alarms will be cleared, right? the previous similar alarms will be cleared in one shot, thanks to the clear trap. Correct?
No. If you've got a different alarm, I mean, you only ever have one alarm of one type of one severity.
Okay.
Okay. So on a particular device, you may have more than one. You may have the same alarm on different devices, but on a particular device, you'll only ever have one, example trap definition raise. For that device, they can only ever have one of those. If any more events come in, then that will be just turn into a duplicated event. It won't create a new alarm. So you can't have an alarm with one severity and an alarm with another severity.
Greg, sorry, I think that Eric is speaking not of alarms that are related to different devices, but actually the same alarm, but for example, different for minor attributes, no? So
yes.
When we say similar, we say alarms that are equal for everything, but apart that are from collateral attributes.
Yes, no? For instance, apart the severity, for instance, yes.
Exactly. Or the text, for example, something like that.
Or the text, yes. Yeah.
In such case, the question is, when you have alarms that are like that, a stream of alarms like that, the clearance close all of them or only one of them?
We may have to come back to this again on Wednesday.
Okay.
The thing is that I think once you've tried a few of these, you'll get a better handle of how it works, right? But the attributes of the alarm are always held in the var binds. Okay. So if you've had a trap come in and it's got attributes associated with that alarm, additional text or whatever, then that will always be part of this mask. So there'll only ever be one event definition corresponding to an event with a set of additional information, because that's the way you have to design it.
Okay, and here in your example, Craig, the event will for sure match with the warning severity and no other severities.
It doesn't match the severity at all. It matches the clear key. Okay, so it matches this UEI. So that UEI is associated with the mask. The severity is something that you have assigned based on your information. Okay. Now, if one of the var binds told you the severity of the alarm, the device is saying, I have a critical alarm, then you would match for that var bind and you'd say, okay, for that particular match, then the severity is going to be, and you'd give it a severity.
Yeah. Okay. Anyway, we will be back on this, I think.
I think the problem is that I want to get us off the theoretical bit and get us onto the example, because I think
okay,
that will
make no issue
a little easier. Okay, it isn't easy, right? I appreciate that, but it's only by practice that we'll get the hang of it. Okay, so hopefully that's given you a bit to think about in terms of, if we've got this mask element and information, we've got the events, how do we then create an alarm? Now, I'm going to jump on to session 3, which is where we would have been, hopefully, if we hadn't had my sickness last week. And what we're going to do is use this example. And this example is basically based on a real example and some real equipment, okay? What we have is a set of cameras on a motorway, and these cameras have a MIB associated with them, okay? And I'll just jump through all of this, because basically this is just setting stuff up that we've done before. What we have associated with this example is a set of MIBs. So if we go into our container and look at SNMP sim where we're doing this and look at the MIBs, you'll see that there are a load of MIBs associated with this particular device. And we need to parse these MIBs. We need to get them into a form that OpenNMS can do something with. And OpenNMS itself has the ability to do that. So if I go to my MIB compiler, you'll see that they've got the ability to upload a MIB. Okay. Now, what I need to do is upload these in the right order. Otherwise, it won't work. And these are the MIBs here that are in my project. Okay. And I'm just going to upload them because uploading them is fine. So, but I need to do them one at a time, unfortunately. Of course, part of the problem with a lot of this is that you generally, have to go and find the MIBs that you need for a particular example. So that's half the work, generally speaking, finding the MIBs that you actually need to do this. Hoping that I have all of them. The one I'm actually interested in is this Chubb DVB-S camera MIB. And if I look at that itself, let's just have a look at it. You can see here, standard MIB definition, but the MIB itself actually depends on other MIBs. So you can see module identity, from SNMI, from Chubb root, from SNMP come from whatever. So you have to upload these MIBs before you can actually do the camera MIB. So you have to compile them first. But the MIB itself, it's got certain amounts of human readable information in it. It's not actually very easy to follow sometimes, but it is human readable. So that can give you clues. But what OpenNMS does is actually puts it in. So let's take that. And can I just ask if you go on mute if you're not asking a question? And I'm going to actually just start with trying to pull in the MIB itself. Okay. So just compile that MIB and you'll see error dependencies, Chubb root, and that are not available. So I have to do those ones first. So let me just start with these ones at the bottom, which I think I probably will need to do. SNIB, SNMI, TC. Good. So I'm gradually able to work my way up. And finally, I can compile the MIBs. So I've now been able to compile all of the MIBs into OpenNMS. Now, all that does is it makes them ready to be used. Doesn't mean that they're actually in OpenNMS and we've already done all our work. We just know that we can parse the MIBs and we've got all the MIBs we need. So we're ready. So now what we need to do is we actually need to create events from that MIB. And we go on the generate events and it offers us a candidate UEI base. So remember, if I go back to this, or I won't go back, but you'll remember that the UEI actually had these bases. So I'll just continue with that. And we can see that this particular MIB has actually got 4 different traps. A health change trap, tamper detected, laundry can be changed, and com state changed. All of different purposes, but it only has 4 traps. Turns out, however, that each of these traps have got multiple variations, so we're going to have to do more. But we've got the events. So let's save this events file. And what we can see is down at the bottom of this that we have saved XML data into user share OpenNMS events, Chubb TBS camera MIB events. And we've added a reference to that in the event.conf.xml. Okay, so that basically is telling us that we have actually added those events into OpenNMS's configuration. But there's not very much information there. It's just going to tell us that there's going to be a trap coming in, but won't give us very much more than just that trap. But let's just say that we've done that. So we've loaded it. We've got it in there. It should now be running within OpenNMS because the events configuration has been reloaded. So let's send that event to OpenNMS. If I go back to the exercise. And what I'm going to do is just pick. Yeah, so I'm going to send this trap to Horizon. I'm actually going to change where I'm sending it from because I want to send it from the Chubb device. So, and I'm going to see where I'm going to send it from. So, I want to send it from this Chubb device rather than from 4. So I'm now in the device. Just go back to that, and then I'm going to send that trap. Right. So I've sent the trap, and I'm going to. I don't need to. Just to remind you, the only thing you need to remember is this actually is going to tell you where the files are in the file system. So you will need that information, but I'm just going to leave this screen now because we don't need it at this point. So just go to Cabra 1. I'm going to look at the events, and you can see. He says, let me just look at the events again and see where I've actually sent that from.
Greg, I think it has not been sent. There was a hash at the starting.
Your star. Thank you so much. Somebody's paying attention. Very good. I would have been like, oh my goodness, what's going on? Right. So good. There we are. So we have an indeterminate alarm. We've no alarms yet. We've just got this trap. Okay. And all it tells us is that, something's happened, basically. We don't know what the severity of it is. We do know that it's got these various var binds associated with it, and we produced some basic log message that's come from the MIB itself, but just enough to get us started, all right? If I send a different value, send that to 0, for instance, and change this to 1. So I'll just send another trap, and we'll see what that looks like. Events. And you can see another one's come in, and it's basically the same thing. So it's telling us something. It's not telling us we don't know anything about this trap, but it's also saying I don't know what to do with it. That just gives me a bit of information. All right. So the next stage then is going to have to be, we're going to have to take this trap and turn it into something much more useful. So what we need to do is we need to get those files out. So this is all instructions for parsing MIB. We've gone through this. What we actually, and we've just tested it now, which is good. What we need to do is we need to copy that file that we have just generated. Remember, the name of the file and the location is given to us in the logs. So you can see here, user share OpenNMS. There's the name of the thing that's been given. Here, we're going to use Docker Compose, copy Horizon, which is obviously the system we're copying from, user share, blah, blah, blah. We're just going to put it at the root of the directory. So let's get out of this. And we'll just run a simple command, Docker Compose that. And we've copied it to that location. And we'll just, by the way, we'll also do the same with the event conf file, which we've generated. And then if I look in my actual project, you can see that I actually have these two new files now. This is what OpenNMS has generated, and this is the event conf. So the event conf, all that's happened is I've added that extra line in at the front that references this file. And then this file here is the actual file that's been generated. We'll just look at this very briefly. A bit bigger. And you can see that from the MIB, OpenNMS has generated all of the event definition. So it's got the mask element, it's got the UEI that we've assigned to it. That health change actually comes from the MIB itself. It's given it an event label, which is good enough. And then it's generated some text for us based on the MIB. So this parameter 1, it's actually picked up from the MIB that parameter 1 can have 12 values, and it's told us what those 12 values might be. That's just in the text. And then for parameter 2, it said if parameter 2 is clear, then it's a 0, and if it's triggered, it's a 1. So that just tells us, well, one's going to be a clearing alarm, one's going to be a triggering trap, okay? And then there's something else in terms of the log message, basically, again, another example. And then interestingly, which is quite useful, it also provides us with what we call a var-bind decode, which for a given parameter will decode the var-bind value into the corresponding decoded string. So that means that if we use these parameter 1 or parameter 2 in our text, instead of just putting the number in, what it'll actually do is it'll put in the pan motor or tilt motor or focus motor or whatever in the text. So this can simplify the process because it's actually creating a lookup table for us within the configuration. But again, this lookup table is coming from the MIB. The MIB's generated as if it wasn't in the MIB, it wouldn't be here. It's useful, but it isn't necessary, and it isn't something
Craig,
that everyone has.
sorry for interrupting you. It's not clear to me, maybe that I didn't understood. How are you, I view the mapping of parameter position, I mean, var-bind 1, 2, 3. So for example, you see the parameter 1 is a change. Okay, false state, parameter 2. Okay.
Okay, so the var-bind position. Okay, so the very important thing to understand about var-binds is that in these configurations, it's the location of the var-bind that's important, not the OID.
Okay.
So if we go to the back to where we were at before. Yeah, 2.3, the exercise. You can see that this var-bind 3, value 1, okay? That is the third var-bind, okay? Now, var-binds themselves, if you look at the trap associated with this, if you go down to here, you can see the trap has, that's the OID of the trap. Then this is the first var-bind. That's the first var-bind, second var-bind, third var-bind.
Okay, yeah.
These var-binds have got OIDs in them, okay? But OpenNMS ignores those OIDs. Most of the time, there are cases where it might look at them, but in this case, it's ignoring the actual OID. So it's not looking up the value by the OID. It's just saying the first value or first var-bind, which is just a name value pair that I encounter, that is var-bind 1. The second one is var-bind 2, the third one's var-bind 3. And OpenNMS doesn't care about what the OID is associated with that. So even though the trap will contain the OID, it's the order in which the var-binds occur in the trap that's important. And in a well-designed system, that will always be the same. It shouldn't move around. And so the expectation is that the the trap will always have the same value at the same location. It won't move the var binds around. And OpenNMS will not look at the OID. It will just look at the position of the var bind to know which one it is.
Okay.
That's a very good question. Thank you very much.
So it means that in the XML file, we cannot use OIDs at all, only positioned.
You can't use OIDs to determine which var bind is part of the mask. That's correct.
Yeah, problem is that I have seen many times that var binds positions are messed.
Yes.
Some vendors have SNMP traps and it causes a lot of issues.
Yes. So the only way to, I mean, obviously if a vendor is actually if a vendor is random, you know, a trap will send the var bind in a different position each time, then that really is a problem, right? I think we've found, generally speaking, it isn't as big a problem as you might think. Vendors tend to be reasonably consistent within themselves, even though they may not be necessarily following the standard properly. So as long as you know which device it is and you know the OID, then you can basically work out which var bind is which. The event translator can look at the var bind values. So that is a way around this problem if it is a problem. But the event translator, really, you only want to use that whenever you've got a much more complex problem to solve. You don't want to use it for every event. You just want to use it for other situations, which we'll come on to.
Craig, the XML file we are currently looking at here.
Yes.
Is it an XML file provided by the camera vendor, or is it a customization done by someone else for OpenNMS?
This XML file is the XML file we generated when we compiled our MIB. So the MIB came from the camera vendor, and OpenNMS has created this XML file from that MIB.
Okay. Okay. So we have nothing to do. It's just the result of the compilation.
That is correct. Okay. Yes.
Okay.
Right. Okay. But you do have things to do, because this isn't enough in itself. This is just a starting point. But what I've shown you is that, if you do that compilation and you send an event, you send a trap, you will get an event that has this information in it. But you're still not there yet. Okay. All right. So what you have to do with this is you have to, first of all, determine, are there any var binds that actually want to generate different events? Now, it's clearly the case that, these are all things that can happen at the same time. The pan motor can go wrong, the zoom motor can go wrong, the heater can go wrong, the fluid level can be empty. They're all independent problems that can happen with a camera. So you can't have one alarm. You have to have an alarm for each one of these to say, the housing temperature is too high, or the washer motor fault has happened, okay? So then it's necessary to be able to create more than one alarm based on the parameter number 1. Okay. And what that means is that this just gives you a starting point. This says that we've got the mask, but we actually need also to create events for pan motor 0, for var bind 1 as 0, as 1, as 2, as 3, as 4. Okay. Because there's going to be events corresponding to each one of these problems. And there's going to be a clear and a trigger associated with that. So the raising event is going to be the trigger event, in which case you'll have a var bind of var bind 2 of value 1. And then the actual UEI is going to be either pan motor, tilt motor, zoom motor, that'll be varbind 1 you're masking on. So you'll have 2 mask elements, 2 varbinds to mask on, and you'll create a new EI for each one of these different types of problem. So I'm going to just jump ahead and show you what the actual result would look like, okay? Just so you've got an idea. These, in my example, I've got, the simple alarms from the MIB, which are just basically what came in from the MIB. It's probably easier if I show you this on GitHub itself. So in session 3. Yeah, under example configurations, there's the actual example configurations here. So events generated from the MIB are the actual raw events that have been generated from the MIB itself. But the example alarms from the MIB are having taken that and processed it. And you'll see that what I've done is I've taken the health change alarm events. So I have said, okay, there are going to be 12 health change alarm events. And I'm going to take the mask element varbind number 2, and it's going to be 1. It's going to be a raise event, okay? And I'm going to take varbind number 2. Sorry. So let me start that again. So that's my health change raise, okay? Because varbind number 2 is a 1. And then further down, I've got a health change clear, and it's a clear event. Okay, you can see that's the clear, and then the alarm data will match that. Now I haven't broken this down into separate separate alarms, right? But I've given you enough to see how it would be done. Okay, so health change clear and health change raise. And then the varbind 2 is 1 or 0. But if we're going to do this properly and create separate events for each one of these, then we'd actually have to create a separate UEI for each one of these types of alarm that we can have, and have a raise and a clear for each one. Okay. So you can see that you start off with something, but then you have to do a lot of work to make it more useful.
But if we have to define a clear for this one, and the reduction clear related is to contain all the varbinds, or not?
I'm
For
sorry.
example, if we have to clear tilt motor.
Yes. So for each of these,
key?
for the you're going to have to create a separate event for each one of these, and a separate clear event for each one of these.
Okay.
Okay.
Actually, these are 12 traps at the end.
So there are effectively 12 event definitions. In fact, there are 24 event definitions.
Okay.
Because there's 12 raises and 12 clears.
Okay.
Okay. And that event that.
Sorry, Craig. And this cannot be done by the compilator itself, by the OpenNMS compilator. This cannot be done. We need to do.
No, because it doesn't know that these values are raises and clears, and if these are separate values. It just, it's done as best it can with the information it's got from the MIB, but the MIB doesn't tell us how to actually create a configuration. That information is only information that you would know if you knew what this trap meant. You can infer it, you can guess that these things mean different things. But the other thing, of course, is that each of these events are going to have a different severity as well. The fact that the wiper motor is not working is it's important, but it's not critical. But if the video is not working, that's critical. Or if the, further down, we've got a temper alarm, so that means somebody's trying to break into the thing. Well, that's critical. So you'll want to assign different severities to each one of these events as well, because some of the alarms are going to be critical and some of them are not going to be critical. And again, that's a decision you have to make.
Got it. Right. We cannot escape this customization work. Okay, I understand.
You can't, unfortunately. Okay. You can get so far, but then you have to, go further. And of course, it's given you a certain amount of text, but this text isn't the most pretty. So again, you may want to step back and say, can I actually make this better in terms of the information that's presented? I might want to change my description to be something actually a lot simpler than this, because this is containing all the information. It's just too much for somebody. You could make it a lot simpler if you wished. But you again have got to decide to do that. This is just giving you a starting point for you to decide to do it.
Okay. Thank you.
Okay. Right. Now,
I think that we have to practice in order to understand whether I really understand how to do it.
Exactly. And that is why this is
otherwise it's not useful. I understand it, which are the directions, but in the end we have to practice.
Yes. So what I've done is I've provided you with this exercise, okay, to work your way through. And what I'm going to ask you to do is basically spend we've finished, I think, what finished at 11, don't we? We basically spend the next half hour at least starting the exercise, and we'll come back to it again on Wednesday. But I would say you need to work your way through this. Go through this exercise, compile the MIBs, and then exercise 3.1 basically says, first of all, check you can send the traps once you've compiled the MIBs. Then get the files out into your system. Identify how raise and clear traps are identified, and create those traps, and then use the masks. Add in the var binds. Decide on the severity. Create a raise and a clear. Then you need to add the reduction key. That will just deduplicate all of those events for you. And then in the clear event, you need to add the clear reduction key. And then you need to test that this thing will work. Now, I have actually provided you with a whole set of example traps here, okay? So these are palm motor raise, palm motor clear, et cetera, et cetera, et cetera. So these traps will all give you, test the result, basically. But you need to work your way through the thing to make sure you understand it. So what I'm going to do is I'm going to maybe split you into groups again for the next half hour. And maybe you can work in your group. I don't know how many exactly there are on, but in your little group, one of you share the screen and just get started really with this and work through the process. And then we will come back to this on Wednesday. And in the meantime, if you've spent some time yourself trying to work your way through, we can answer questions on Wednesday, but we can also then, make sure and see how you've done it. I don't expect you to finish all of this. If you were going to finish it, it would take you a lot of time. But I do expect you to understand what it would take to finish it, because this is the nuts and bolts of what you actually have to do if you come up with a new MIB that you need to parse. And it's really important that you understand how that process is done.
Okay. Craig, do we have to complete session 2 also to start with session 3? Any dependencies?
Session 2, I mean, I've covered the stuff that's in session 2. It's a softer introduction. I'm afraid I've rushed through it. So session 3 would come into very, very hard. But, if there's nothing in session 2 that I haven't really covered here, it's useful for you to go back and look at that, but you don't need to cover that to be able to do this.
Okay.
Okay. So remember the example traps are there. And what I'm going to do is put you into groups, and then you can have a go in your group to I'll just create 3 breakout rooms and just assign yourself to a room and then agree among yourselves how you want to proceed. And it's exercise 3 that you're trying to do, okay? Any questions before we go?
No.
No.
Okay. Hello, room 1.
Hello, Craig. You're on mute, Craig. We are not hearing you.
You are now. Sorry to bring you all back, but we've kind of reached the end of the 2 hours. So, and probably everybody's enough by now. Well done. I was in one of the rooms, or a couple of the rooms with you, and I know Ronnie was there as well. I'll just introduce Ronnie Tromer. Ronnie's going to be doing the session tomorrow, looking at performance management. Ronnie, maybe you could just say a couple of words before we go.
Good morning, Ronnie.
Hello, good morning. Sorry, my little one came home just
You
a
will
minute ago.
you will suffer a lot tomorrow. You will see. You will suffer.
No, I don't. For sure not.
Yeah, so Ronnie will be taking tomorrow's session, which is going to be in performance, and then we'll come back to this painful alarm management exercise on Wednesday. I know people have sort of just woken up to it and trying to get their heads around it, but if you've got time and you could spend some time trying to work your way through the exercise, then we'll cover it again on Wednesday, but then we'll go on to some more alarm management stuff on Wednesday as well. But Ronnie's going to go off on a different tangent tomorrow, looking at performance. Any questions on what we've done before we go?
Craig, we have exactly the same issues with the 2 students, Dockers. Can you look into the chat? There is a message about Horizon ports on startup. It's from Jeremy.
I can't see any message, actually, to be honest. Can somebody just put that again?
Yeah, I looked into the chat as well. It's pretty empty, maybe.
Okay. We pasted chat probably in our room.
Yeah, in the break room, so we don't. Yeah, thanks for.
Right. Yes.
I pasted the message back again to the chat.
Yeah. But this was on Docker Compose. You're finding this, yeah?
Yes. This is a TCP port conflict on 61616.
Yeah. I'll be honest and say that I have seen this before, and it cleared itself eventually, and I never had it again. So I don't actually know what the problem is, but it's a Docker problem. What you can do is the line that references 61616 in the Docker Compose, you can comment that out, and then you won't have the port conflict on your main machine. The 61616 is being used for ActiveMQ, but you don't need to access ActiveMQ from the host. You just need to access it locally inside the Docker container. So I think just comment that line out, and that problem should go away as a temporary fix at least.
Okay. Any possibility for a conflict from the previous labs? Maybe we have to clean up something from the previous labs, or?
Yeah, that's definitely a good hint. So you need to stop any container which exposing that port as well. So if you have like a earlier lab running, which exposes also 61616 for ActiveMQ, you get a conflict because it can't bind the same port twice to two containers.
Yeah.
Cool.
Yeah, exactly. That's
Yeah.
why I always say when you're starting a new session, do Docker compose down -v on the previous session, so that you've got rid of it basically. So when you end, clear everything up before you move on to the next session.
And another topic I've seen, like in the team I joined, was the ping command wasn't available from that camera containers.
Yeah,
because it's like a very minimal operating system.
Yeah. So there is actually a Docker file in example 3 that actually adds that in. So what you'll need to do is Docker compose build before you do Docker compose.
I see the instruction here. So yeah, if you rebuild it again, then you have the ping utilities installed. Okay.
Okay, thank you.
Any other questions? There's not enough time. There's never enough time.
It's more Docker troubleshooting.
All right. Well, thank you very much for your attention, folks. And we'll see you tomorrow. And we'll be in Ronnie's capable hands.
Thanks a lot.
Thank you.
Enjoy your day.
Bye.
Thank you.
Thanks.
See you
Bye.
tomorrow.
Thank you very much.
See you tomorrow.
Bye bye.